Hey everyone. So I look forward to looking at the blueprints of your house, and we are going to be coming back to that later. But first, we need to do some review of some other geometric concepts. And for example, today we are going to review the concept of area, and then we're going to explore the relationship of the area of an actual shape compared to a scale copy, because there's an interesting relationship that shows up. Now, today our task is we're doing explorations to discover this pattern. You are going to be asked to make a table in your notebook for each exploration. I will have the table as well, so don't worry, you just have to follow along with this video. And we're going to hopefully represent and find a relationship from the original copy to the area of the scaled copy. You're going to see that it's going to be a similar structure for each geometric shape that we are going to do. We are looking at parallelograms, triangles, trapezoids, and circles today. So we're going to do 4. So here's the first one. Below are 2 parallelograms. Now, a parallelogram is a geometric shape that has 2 pairs of opposite sides that are parallel. So for example, rectangles, squares, those are parallelograms. But also this photo on the right is also a parallelogram because the top sides are parallel to one another. And these sides are parallel to one another. Now, in all cases, the area of a parallelogram is the base multiplied by the height. Notice I'm not using length and width because this parallelogram doesn't have a length and width that we can use. Base and height always works. Now, it's key to note about the height. The height results in a right angle. So notice, even if I knew that, say, this yellow line was 8, I wouldn't be using that. I'm using the 7.8, which represents the height, the straight down. You don't measure diagonally, you measure straight down. So find the area of both of these parallelograms on your own. Don't forget, we always label with units. Go ahead. So our first one, we have a base of 8 and a height of 6 because it's a rectangle. So our area is 8 times 6, which is 48 units squared, because I am also multiplying the units by units. And when we multiply units by units, we get units squared. So for the second one, I have 7.8 yards multiplied by 11 yards. Well, the 7.8 times 11 is 85.8. And we have a yards multiplied by a yards, which is yards squared. It's almost just like combining like terms. When we multiply a 2 by 2, we get 4, which is 2 squared. So here is now how we're going to do an exploration. Now, we are going to use our original copy for the first rectangle. So that's the blue one. Our base is 8 units. Our height is 6 units. And we realize that our area is 48 units squared. Now I'm going to help with the first row. So I'm told that the scale copy with a SF, so scale factor of 2. So that means each measurement is multiplied by 2. 8 times 2, so I have a 16 units. A 6 times 2 equals a 12 units. And now I'm going to find my area, which is a 16 units multiplied by 12 units. And when I do that, I get that the area is 192 units squared. So hopefully you're starting to think, because the idea is this is an exploration, so we want to try to find a pattern. I doubled the base, I doubled the height, and the area, it's not doubled, it's more than doubled. So I'm going to pause, and you are going to fill out the information for the next 2 rows in your notebook. Make sure you show your work. So here's the rest of our table. And we're trying to think, okay, so original to scale factor. Well, all right, let's start thinking. To get from here to here, it ended up being a times 4. It's 4 times larger. Well, from here to here, well, it ended up being 9 times larger. And last but not least, to get from my original to this one, it ended up being that the area was times by a 4th, which is also dividing by 4. I'm just going to leave it at that, but hopefully you're starting to think of some potential reasons for why that might be. Because anything we figure out, it means we just get to do shortcuts. It means we can go straight from the area of the original to the area of the scaled copy. That saves us a lot of time. We only have to do 1 measurement instead of 3 in this case. All right. So let's take a look at triangle. So triangle is a 3-sided geometric shape. Now there's many types of triangles, and we're going to explore some later. But as a reminder, the area is base times height divided by 2. Some people write it as this, 1/2 base height. And the height, again, it's wherever it creates a 90 degrees. So here are 2 triangles below. See if you can find the area. Go ahead. So this one is easier to see because we see that the base is 10. The base doesn't always have to be on the bottom. The base is the side that is using the height, that's attached to the height. So I have my base multiplied by my height divided by, whoops, I was about to write 5, 2. Well, that ends up becoming 46 centimeters squared. Now here we have to count. We see that the base is 1, 2, 3, 1, 2, 3, 4, 5. My height, again, it's the straight down to wherever the base is. And we do that. That is a height of 3. So therefore, our area is 3 times 5 divided by 2. That's 7.5 units squared. All right. Now, same exact thing as before. We have exploration, but this time we're going to do the second triangle. See, it's a second there. So my original base is 10. My height is 9.2 centimeters. My area we discovered was 46 centimeters. So here are your scale factors. Fill out the table in your notebook, and let's see what we get as a pattern. So here is the table filled out. If you need to, pause the video to make sure that yours matches up. So for scale factor, I multiplied the base and height by 5. For 10 by 10. For 1/5, I actually divided by 5 because that's the same thing. I then did the area formula to find the area. Now again, we're trying to find a pattern. So I'm like, okay, from 46 to 1150. Well, I multiplied by 5. Is it 5 times? No. It ends up being 25 times. Okay. Well, is it 10 times? No, it ends up being 100 times to get from there to there. From here to here, we divided by 5 for the side lengths, but we ended up dividing by 25 or 1/25th to get to there. I hope we're starting to see something. So again, the scale factor was 5, but the area was multiplied by 25. The scale factor was 10, but our area was multiplied by 100. The scale factor was 1/5, so divide by 5, but we divided by 25. Up here, our scale factor was 2, we multiplied by 4 for the area. Our scale factor was 3, we multiplied by 9. Let's go to our next exploration. Trapezoid. So, our area of our trapezoid, it's the sum of the bases, so base 1 plus base 2, all multiplied by the height, again, look for that 90-degree angle, divided by 2. So if I was to do this one on the right, this represents a base 1, this is my base 2, and that is my height. So my area is 6 plus 8 multiplied by 4 divided by 2, which ends up getting a 28 units squared. So you do the one on the left now. Here's the answer to this one. Now, just like we've been doing, here is, so our original, I'm asking for the second. So my first base was 8, my second base was 6, my height was 4, and we discovered that our area was 28 units squared. So I want you to fill this in unless you think you can start to find the pattern. For example, I know that the area for a scale copy with a scale factor of 2 is 112 units squared. If you think you can go straight to the area, go right ahead. If you see that you get it wrong when you input it into the answer, you then have to do first base, second base, height, and I should see that in your notes. Go ahead. So here are the answers. Well, this was 4 times. This was 16 times. This was 1/16 of the original, or dividing by 16. And last but not least, this was multiplying by 9/4, or that's the same as 2.25. Hopefully we're seeing a pattern. So last but not least, circles. The area of a circle is the radius squared times pi. Now for a circle, the radius is from the center out to the side. The diameter is the whole thing, also known as 2 radii. Now, for pi, for right now, pi is about 3.14, and that is what I want you to use when finding the area of these circles. Go ahead. So the first one, we already have the radius. So the area is equivalent to 9 squared times pi. So that's an 81 multiplied by, we're using 3.14. And therefore we get 254.34 centimeters squared. Now for here, we have the diameter. So I first have to take the diameter and divide by 2, which gets me the radius, because the diameter is 2 radiuses. So my area is 21 squared times pi. And when I use my calculator to do that, and again, I'm using 3.14, I get that my area is 1,384.74 centimeters squared. We're going to do one last exploration, and we are going to be using the second circle. So we know our diameter is 42, so our radius is 21. We use 3.14, and we get 1,384.74 centimeters squared. Now, my goal is for you to not need to fill in the diameter and radius, and to go straight to the area using the patterns you've observed. So see if you can do that. Otherwise, find the values of the diameter and radius and then find the area. Go ahead. Here is the last one. Now, let's see. My scale factor was 4. I multiplied by 16. My scale factor was 10. I multiplied by 100. My scale factor was 1/3. I multiplied by 1/9. Well, 4 squared, maybe area is units squared. 16, that's what I had to multiply by area. The scale factor was 10. 10 squared is 100. The scale factor was 1/3 squared, which is 1/9, which is dividing by 9. And that was the pattern. Area is units squared. So the scale factor is taken into account twice. So here's our conclusion. When comparing the area of the original to the scaled, think about how many times you multiply. That's why we have units squared. So therefore, we are multiplying in a parallelogram, the base times height. So that has the scaled factor twice. So what we end up noticing is that the area of the scaled copy is the area of the original copy just multiplied by the scale factor squared. Or you can go the other way. The area of the original copy is the area of the scaled copy divided by the scale factor squared. So make sure we've added this conclusion into our notes. If you now have it included, I have a 3-question exit ticket for you to do. I expect to see some work in your notebook for this when you upload it. So make sure you also read the feedback at the end of each question. Have a great rest of your day, guys. Bye.